Algebra 2, this is Chapter 7, Section 5. Then I'm going to have, this will be Example 2 with Descartes' rule of signs, and I'll do Example 2 with two different examples. So I hope this might be a little long of a video. Hopefully this will give you a full explanation of Descartes and the rule of signs. So if you've got any polynomial with real coefficients, which means the numbers in front of the variables are just real numbers, then if we arrange them in descending order, which means that we have like 3x to the fourth minus 2x to the third plus x plus 1, these powers are going to be going down. That's what descending orders means, descending orders of powers. Then the number of positive real zeros, and this is kind of weird, but it works, is the same as the number of sign changes in coefficient. What does that even mean? Well, I'm going to go through two examples, and hopefully by the end of the second example you'll catch on to this. Or lessen this by an even number. Hopefully you've understood that when you have a imaginary root, you have to have two imaginary roots. You can't just have one. You'd have a plus or minus I in with that. And so they go down by even numbers, by groups of two. Same thing with the negative. We actually take and we put a negative x in and find that functional value. Then we're going to again count our sign changes, and it's going to be that many. Sign changes will be the number of roots that are negative or down by an even amount. And this seems really confusing. Let's go through an example. So here I have a polynomial, and it is in descending order, so 5, 4, 3, 2, this is a 1, and that's a 0. And if I just count the sign changes, this is plus to minus, so there's 1, and then to minus, and then to minus to plus. So we're going to go, here's 1, here's 2, here's 3, and there's 4. This is not a sign change. It goes from negative to negative, so no sign change. So we have a total of 4 sign changes. So we would have 4 or 2 or 0 positive real roots. We're not sure which, but it's either going to be a 4, a 2, or a 0. So then if I find p of negative x, let's let myself a lot of room here. So if I take a negative to the 5th power, that is going to be a negative, so this is going to be negative x to the 5th. And then to the 4th power, we'd leave it the same, so that's still going to be 6x to the 4th. To the 3rd is going to change the sign, and negative to the 3rd power changes the sign, so this becomes a positive 3x cubed. Squared leaves the sign alone, so that's going to say positive 7x squared. X to the 1st is going to change the sign, so that's going to be a plus 8 and a plus 1. Now we got to change counter sign changes. So it goes negative to negative, that's not a change. And negative to positive, that's 1. And then they were stay positive, so we could have 1. And we could have 4, 2, or 0 positive real roots. So that leaves imaginary roots. And we know that we are to the 5th power, so we would have 5 total answers here. So it would be 4 and 1 makes 5. That would already be 5, so there would be 0 left to give us our 5 here. If we've got 2 here and 1 here, again, this total needs to be 5 the whole way down here. So 2 plus 1 is 3, plus 2 more would give us our 5. And 0 plus 1 is 1, plus 4 more will give us our 5. So these would be the way our roots could possibly work out. We could have 4 real positives, 1 negative with no imaginaries, 2 positive reals, 1 negative real with 2 imaginaries, or 0 positive reals, 1 negative real with 4 imaginaries. And this kind of helps us narrow down our search when we go to find all of these zeros. So let's go through that one more time. So we are to the power of 6, and hold on a second. Okay, so we're to the power of 6 here. So let's count our change in signs. So we go from positive to negative to positive, that's 1. Positive to negative, that's going to be the second one. Negative to negative, negative to negative. So we change signs 2 times. So we are either 2 or 0. Okay, and I'm going to put my 0 here. Now let's go with P of a negative x. And this will, once we fill that in, we can count our sign changes to find our negative reals. So a negative to an even power stays the same. So it's going to be negative x to the 6th. A negative to an odd power changes the sign. So it's going to be minus 4x to the 3rd. And a negative to the even power, again, is going to leave it alone. So that's minus 2x squared. And a negative to the first power is an odd power, so that's going to change it. And then plus 1, or that's a minus 1. So we're ready to count our sign changes. So negative to negative, no change. Negative to negative, no change. Negative to positive, 1 change. Positive to negative, second change. So we've got 2 changes there. Okay, so we could have 2 positive reals with 2 negative reals. We could have 0 positive reals with 2 negative reals. Or we could have, let's go 2 and 0 again. And we're just trying to make a sample space of all possible outcomes. This could be 0 and 0. And then we've got to figure in our totals. We have this to the 6th power, so this is going to be a 6 here. 6, 6, 6, and now we can fill in our imaginaries. So if we've got 2, 4, we need 2 more to get 6. We could have 0, 2, we would have 4 more to get to our 6. 2, 0, we would need 4 more to get to our 6. Or all 6 of them could be imaginary. So we could have, with our imaginary zeros, 2, 4, or 6 imaginaries, 2 negative reals and 0 negative reals, and 2 positive reals or 0 positive reals. And that's all the possibilities of how our solutions might possibly come out. And we'll get to future examples here which show us what we're going to do with that information. Hopefully you understand how to fill in this table to get the different types of solutions we're looking for.